Hi, my name's Ben Marler and I'm a PhD student in Materials Science at the Extreme and Emerging Materials Lab at Trobe Bendigo. I want to introduce you to this lab and why I chose to come to Trobe. Here at this lab, we have a one-of-a-kind facility for nanotechnology and specifically creating new materials. What makes this lab unique in the entire world is instead of creating tiny, minute amounts of materials like all other labs do, we can create materials meter by meter, but at microscopic resolution. So imagine being able to 3D print, but with any material you can imagine, at the highest resolution, higher than any other printer by 1,000 or even 1,000,000 times. If we want to move over to this side, you'll see a pattern in this room. One of our sort of secrets to making large quantities of brand new materials that have never existed before is pressure. So my system is the highest pressure system in the world, but we can actually go higher pressure with this diamond anvil cell system. A laser shines between two diamonds pushed together, achieving pressures higher than underneath the crust of the earth. Come over here and it gets even more extreme. On our ultra short Z-pinch microchemistry system, we have a very high current that goes through a laser and can crush a capsule, producing pressures even higher than if a meteor hit the earth. So we can actually create materials that are extremely rare on Earth, such as lonsdaleite, which is only found in one place on the entire surface of the planet. Some of these materials may hold the secrets to new medical devices or new electronics, maybe even quantum computing. Last of all, let me introduce you to this system, our automated materials discovery system. Using our unique technology and using really the campus that we have here, we can team up all these other scientists that you've seen at these other labs. We're bringing our robotics guys, our computer science guys, and together we can automatically discover materials of the future. Right now, worldwide, labs might, on a good day, discover 10 new materials. Once this thing's running 24/7, we're talking about 200,000 new materials a day, and that's discovered, characterized, and all the data ready to be published and shared with the world. So that kind of just shows how, at La Trobe, and really only here, do you have on the same floor all of these world-class scientists from different disciplines. I feel super lucky that I was able to come here, and that's actually because I was originally from a medical background, but that's kind of how it works here. You can have these different backgrounds and interests, and you won't get pigeonholed and told, okay, you're just stuck doing this for the rest of your life, whether you like it or not. La Trobe is a place where the faculty will use their expertise, they'll spend time with you, and you can actually then get access to machines like these ones and the mentoring to make it happen and get your research out to the world and out to industry. So that might sound a little bit cheesy, but that's actually why I came here. I hope that whatever you guys go with, you can find something like that where you go to university.
Welcome to Civil and Structures Engineering Lab. Hi, this is Vipul Patel. I'm a lecturer in Civil Engineering degree. Let's check it out, some new equipments here. We have universal testing machines here that help the students to learn their experience. We have a laser slipper testers that also help the students to learn hands-on experience. We have various beams testing machines as well that help us to do the concrete beam and concrete slabs. Also, we have various options to take the transportation, civil engineering, hydraulic engineering degrees. Thank you.
G'day, I'm Emily Good and I am one of the teaching assistants and I'm also a PhD student here. So I'm doing my research here in our water tech lab. So I'm just going to be going through a couple of the features here that both our undergrad and our research students get to use. So this piece here, shows you pipe friction. So we can visually see, and this is why I love this piece, we can visually see where the bends are and how that affects our system by running water through of different pressures, different types of water, so we can actually see our losses, which is really important for our students to understand if they're designing pipe systems. So here is one of our angle testing pieces of equipment. So this is a hydraulic bench. We can change out the different pieces of equipment. You'll notice we have a couple of these around the lab, so we can do multiple experiments at once. The piece I have set up here is, I personally call the fountain piece, but what it does is it actually shows different angles and their effect on water, the losses that are involved, how much erosion is caused by the angle, and you'll get to test this as part of your labs in your undergrad course. We'll keep going. So here we have one of our research pieces of equipment. So this is the first one of its kind in Australia. So this piece of equipment is so detailed that you can put a drop of a chemical in a creek or a river, and then what we actually do with it, one of the uses for it, is we then can work out where the water's flowing in the river and what creeks and what concentrations and what percentage works out by analysing drops of water further down. So we use plasma rays to actually excite the chemicals in here so we can identify it based on the wavelengths they give off. So I will be using this as part of my research, and it's really exciting to have equipment like this at La Trobe. So thank you for joining us for our tour around. We have a couple of things we didn't get to show you today, but if you come to the university and in our classes, we can definitely go through that detail.
Hi, welcome to the Polymer Composites Lab. My name is Rakesh. I'm doing my PhD in the Department of Engineering. This lab particularly focuses on advanced materials and manufacturing. We have different kinds of equipment which we can prepare the polymer composites and do different kinds of evaluation for the characteristics of mechanical, electrical, thermal, and fire retardant properties. So coming to the lab, we have the filament extruders, which we can extrude the filament for 3D printing, where we can produce our own filament by using the recyclable products, where we can produce the polymers and the polymers from the plastic waste and produce the pallets by using the equipment over there, different kinds of polymer waste into the small pieces and produce the plastic waste into the pallets form by using the batch mixer and the extruder. From this extruder, we can produce the filament by using this filament extruder, and this filament can be used for the 3D printing process, where we can produce DIY products and for different kinds of applications. This is one of the different kind of 3D printer where we produce the natural fibers and polymer composites. Natural fibers like nylon, textiles, and different kinds of products where we can produce the products and test the mechanical properties, whether it's applicable in the different various applications like in automobile interior or aerospace interior. This is another kind of a printer where we can produce the basic models like biomedical scaffold models, where we can this is one of the undergraduate program where we teach about how to produce the 3D printed part of biomedical models. And this is another kind of the 3D printer where is basically expose the students how we produce in the bioprinted scaffolds by using different kinds of materials. Here we are producing one of the human ear in the basic scaffold modeling, and it is like a advanced materials and manufacturing process. Yeah, this is a laser cutting machine where we produce various objects for manufacturing or automobile or aerospace application, and this is exposed to the students how to produce the G code and M codes to design the models. This is one of the mechanical testing properties mission where we expose the student how to test the mechanical properties of different kinds of materials, and this mission works on how much strength it holds and what kind of properties it's involved. Thanks for joining in Polymer Composites Lab. We look forward to see you studying here at La Trobe University.
Okay, this is one I'm really excited about. This industrial multi-axis construction arm. It can do a lot of things. We've been showing it off to draw pictures of X-Wings and TIE fighters. But the real reason why I like this robotic arm is because we're using this to create a new therapeutic device for people with foot problems. This machine is going to be used to press insoles out of foam, customized to people's individual needs. But that's not the real reason. That's great technology. But what I love about it is because that's industry level research, a new technology being made by an undergraduate student. Because she was really interested in making something new. And she went to her professor, and instead of the professor saying, oh, well, you really have to be a master's student or a PhD student or a research level student, she was able to do this in her first degree. And that's how we like to work at La Trobe. I've been lucky over the years at other institutions to find what I felt like was favour in the eyes of a professor. But La Trobe has recognised that if we give everybody a chance, if they're just really interested in doing research and inventing, and we throw the materials at them and mentor them, then they can do great things. And this is just one example of that. And I believe that's something that you could achieve too. You don't have to wait years and years before you get started in doing what you really love to do.